Ever wondered why AI systems sometimes fail to collaborate effectively? Like, how do two AIs really work together to solve a complex problem? Today, we're diving into a groundbreaking technique called State Delta Encoding, a method that lets AIs think in unison rather than just exchanging words. Let's start with the problem. When AIs communicate, they typically rely on natural language just like humans. But here's the catch. When an AI generates a response, it's not just outputting text. It's navigating a series of hidden states, internal representations of its reasoning process. However, these states are lost when the AI sends its final answer. It's like handing someone a finished puzzle without showing them the pieces. The second AI has no idea how the first one arrived at the solution. So how do we fix this? Enter State Delta Encoding, SDE. Think of it as a shared notebook between AIs. Instead of just sharing the final answer, the first AI transmits changes in its internal state as it processes information. These deltas act as a trail of breadcrumbs. I considered this, then that, then this other thing. The second AI uses these deltas to reconstruct the reasoning behind the answer, not just the answer itself. And it works. In experiments, systems using SDE solved complex tasks up to 17.3% better than traditional methods. Imagine two AIs debating a math problem. One says the answer is 42. With SDE, the second AI doesn't just accept that, it sees the steps that led to 42. It can verify logic, build on the reasoning, or even ask clarifying questions. It's like a study group where everyone shares their scratch work. Here's the technical breakdown. When an AI generates a sentence, it doesn't just send the words. It also transmits state deltas, snapshots of how its internal brain evolved with each step. These deltas are like GPS coordinates for the AI's thinking. Researchers discovered that focusing on the middle to late layers of the AI's architecture, like layer 22 in some models, yields the best results. It's akin to selecting the most critical clues in a mystery. But here's the twist: SDE doesn't slow things down. It's like adding a shortcut to a highway without closing lanes. The AI maintains its speed, but gains a deeper understanding. And it's compatible across models, whether they're solving puzzles, debating topics, or even detecting AI hallucinations. Those fabricated facts AIs sometimes generate. So why does this matter? As AIs take on roles in medicine, climate science, and beyond, their ability to collaborate will define their impact. SDE isn't just a tweak, it's a leap toward AIs that don't just talk but understand each other. What do you think? If AIs could share their thought processes as seamlessly as we do, what amazing breakthroughs could they achieve together? Let me know in the comments, because the future of AI is still being written. Hey there! Ever wonder how AI systems tackle everything from math problems to fact-checking? Let's break down the science behind it, without the jargon. Imagine an AI as a problem solver. Sometimes it works alone, a single-agent system, like a solo musician nailing a melody. For tasks like math equations or straightforward facts, this works great. The AI follows a step-by-step plan, like solving a puzzle on its own. But when the challenge gets trickier, like debating a complex topic or unraveling a mystery, AI teams step in. Think of it as a group of experts brainstorming. Each agent shares their answer, then they discuss and refine their thinking. It's like a debate club for machines. But here's where it gets interesting. How do researchers train these AI systems to think better? They experiment with something called layer selection, a fancy way of tweaking the AI's brain. Imagine the AI's mind as layers of a cake. Researchers tested 3 approaches. 1. Top layers only, like focusing on the most important brain regions. 2. Mixing layers, combining different parts. 3. Rewriting the whole cake, changing everything at once. Guess what? The best results came from tweaking just the top layers, like giving the AI a targeted boost. Why? Because overhauling the entire system. That's a mess. It's like trying to fix a car by replacing every part at once. You might break things. So what does this mean for real-world tasks? For fact-checking, AI acts like a detective cross-referencing clues. For math, it's all about step-by-step logic. And when teamwork matters, AI agents collaborate like a brainstorming session. The key: tailoring the approach to the task. Next time you see an AI answer a question, remember, it's not just magic. It's a mix of solo work, teamwork, and clever brain tweaking. Stay curious, because the future of AI is still being written.